on the measurements of the variable. Goodness of measures. Goodness of measures. How to be sure that this measure or this scale that we choose is good, and how can we prove that goodness? Actually, goodness of data can be measured in terms of reliability and validity. You know what's the meaning of reliability, of course. When we say something is reliable, it means its performance is stable through the time. So it's reliable. So reliability, you have also two issues, which are stability and consistency. When we say something consistent, means it seems the same, or it keeps its performance through the time. So it's consistent. Its performance now maybe is identical to its performance after maybe 2 hours, 3 hours. So it is consistent. Stability also, we have inside the stability test, retest reliability, and parallel form reliability. In consistency, we have inter-atom consistency reliability and split half reliability. In validity, are we measuring the right thing? When we validate something, we want to be sure that we are measuring the things that we're supposed to measure. We are not doing something else. So we have logical validity in terms of content, phase validity, criterion-related validity, predictive or concurrent, and concurrent validity or construct. So all these things are measures for the goodness. Okay? Here in this table, the meaning of each validity measure of these things. For example, content validity, does the measure adequately measure the concept? If it is measuring the concept enough, means adequately means enough. If it is enough to measure the concept, this is what we mean by content validity. Phase validity, do experts validate that the instrument measures what its name suggests measures, mapping between the name and what it's supposed to do. So if the name of this measure is expressing the things that this measure is doing, so this is what we call phase validity. Do experts validate that the instrument measures what its name suggests it measures? Criterion-related validity, does the measure differentiate in a manner that helps to predict a criterion variable? So all these things are just measures. When you do your analysis of the data and you get your results, how to be sure that these results are okay and the measures that you use are good enough. So it is a kind of advanced things that you can understand later on. So don't worry if you don't understand some of them now, just to know about them, okay? Don't worry. At least you can understand what we mean by reliability, stability. Reliability of measure indicates extent to which it is without bias, okay? You are progressing well without biasing, without leading to some point, okay? So the measure is fair for all cases, for all instances. There is no bias. And hence ensure consistent measurement across time. So it's stability. This is what we mean by stability, means consistent measurement. And across the various items in the instrument. Internal consistency. These are the meanings of these things. Internal consistency and retest, test, retest, reliability. So stability is a consistent measurement across time, and internal consistency means across the various items in the instrument itself. Stability is the ability of a measure to remain the same over time. So, over the time, the progression of the measure is stable, is the same, remain the same over the time, and controllable testing conditions or the state of the respondents themselves. So we have retest reliability, the reliability coefficient obtained with repetition of the same measure on a second occasion. Retest means we repeat. Okay, the reliability coefficient obtained with a repetition. Repetition means we repeat the experiment on the same measure on a second occasion. We make it in the first occasion and then in the second occasion we repeat it and we get the reliability coefficient. This reliability coefficient, which is doing twice, called retest reliability. We have different type of reliability, which is called parallel form reliability. Means responses on two comparable sets of measures having the same construct are highly correlated. At the same time, the first one is test and retest again. But the second one, which is parallel, you can do it at the same time. So you can measure the correlation. If they are highly correlated or low correlated. Actually, all of these functions, correlation functions and all of these, you can obtain them or you can do them through SPSS or Excel. Even Excel, you can do the correlation between some items or between some measures. Anyway, these kinds of measures for the goodness, for the scale that you use, are kind of advanced topics for the analysis of data. So what we need from you from this subject is to understand at least the basics, okay, of the analysis. When you go in deep with analysis, then maybe you will need this kind of measures. Internal consistency, what do we mean by internal consistency of the measure is indicative of the homogeneity of the items in the measure. Homogeneity means similarity. If all the items in the measure are similar from the same type, then they call it homogeneity. Heterogeneity is if they are from different sources or from different nature.
Not chocolate. Chocolate.
Similar. Homogeneous means similar, or from the same source, or from the same type, or from the same nature. But heterogeneous is different. It's the opposite. If they are from different sources, if they are from different natures. So internal consistency measure is indicated, it indicates that of the homogeneity of the items in the measure that have the construct. So if the items are homogeneous, then we call it internal consistency. This item or this measure has internal consistency, or if its items are homogeneous. Inter-item consistency reliability, this is a test of the consistency of respondents' answers to all the items in a measure. You will need this in questionnaire. If you are doing questionnaire and you have some respondents who are biased. So how you are going to measure that this respondent is biasing from others? Of course, you will not see his or her answers because it's difficult in the analysis because you already changed or coding all things into numbers. So you cannot figure out if this one is biasing or not. But from these ways, using this term, inter-item consistency reliability, it is a test of the consistency of respondents' answers to all the items in a measure. So we will look for the measure and compare if this respondent answers two others items in the measure. Okay? The most popular test of inter-item consistency reliability, they call it Cron-Pash coefficient alpha. This is a statistical test. You just apply some kind of statistical equations, and then you will understand or you will figure out if this respondent is consistent, if it has inter-item consistency or not. Split half reliability reflects the correlations between two halves of an instrument. If you have one instrument and this instrument split into two halves, if there is a correlations means some types of you take it in statistics. What do you mean by correlation? Correlation means if this item behaves in some way, the other one should behave in a pattern similar, or you can find the relation.
Yes, it has a relation.
Yes, you can determine a relation between the two parts. So you can say these two parts are correlated. So how degree of correlation can be highly correlated or low correlated. Okay. So as I said in the beginning of this lecture, that most of these things are or belongs to statistics. So we need to review your statistics.
Actually, the correlation studied that by building a linear model between one variable and the other. With the equation and then with the graph, see how the variables related to that.
Yes. This is if you have just two variables, then you can
have
balance. If you have more than one, then you have to move on. You will need statistics for sure in your projects. So put it in your mind, in your plan. When you do your real project for your master thesis, so statistics is a must. Applied statistics. You can find a lot of lessons on YouTube. Just open and watch. But we'll turn back to our problem. Electricity. Okay, anyone has a question? The next lecture we will talk about sampling, how to choose samples from your data that you have already collected, or how to choose a sample to be collected. And the last two things that we will learn in this subject are how to make a quantitative analysis and qualitative analysis. What are the differences between them, and what are the things that we should do to do quantitative or qualitative analysis. And if we still have one lecture, maybe, then we will give you some information on how to write papers, what are the type of research papers,
The publishing.
yes, about publication. Because you're supposed to publish at least one article, one or two articles for your graduation. Okay? Do you have any question?
When I use the display of instrument,
Huh?
when I use
All these things
this,
during your data analysis. Data analysis is the last thing of your experimental design. You said in experimental design, first we need to do the data collection and then to determine the measures. So the measures we studied just today, and then doing your data analysis. Data analysis is usually performed using some statistical analysis test. So all these things are related to statistical analysis. How to validate, how to be sure that our analysis or our measures or data are consistent, okay, are not biasing. All these things relate to the last part of your research design, which is data analysis. And after you finish your data analysis, you go to the interpretation of the data, explain how this one behaved like this and how that one behaved like that. And when you finish your interpretation of your results, you will be writing your master thesis. And by that time, I hope the electricity is stable. Because in writing, you will need a very special, it's very difficult, it's not easy to write a thesis which is consistent. I mean, not to write chapter 1 maybe in January and then stay 2 months, and then after that you write chapter 2, after that you write 1 or 2 months, you write chapter 3, then your writing will not be consistent. You need a flow for writing to be consistent. Okay?
So I think that would be the plan of the thesis work for the proposal.
Yes, you must have
Otherwise, you will lose.
If your topic is well organized, you know what are you going to do. But if you don't know what are you going to do, you are just switching from topic to topic every time, then you will lose the time. So this is what I told you from the beginning. Choose your topic of interest. There is no topic which is easy and other topic which is difficult. Everything is research. But if you have the interest, then you can make it easy.